Hello students, this is Mr. Bornheimer, and this morning we are going to take just a few notes on energy. So if you can grab a piece of paper and something to write with, that'd be great. And here we go. When we're talking about energy, one of the neat things is that there's just lots of different types. And so we're going to focus in today especially on two different types of energy, and they are two different types of energy we've actually addressed in class. The first is going to be kinetic energy. And I'm going to kind of zoom in on this a little bit because I want to break it down. The word kinetic actually has this prefix at the beginning. I'm going to kind of highlight it for you. And this prefix actually is from the Greek. And it actually means movement. So one of the things you can probably guess right off the bat is that if we were to replace this word kinetic with its fundamental meaning, which is movement, we end up with this idea of movement energy. Okay, and so one of the things that I want you to kind of think about right now is what kinds of ways do we see this movement energy change? If something is going slow, does it have movement energy? If it goes fast, does it have movement energy? If it's standing still, does it have movement energy? And so one of the things we kind of have to ask ourselves is to look at various scenarios. So let's do that. Let's say that we have a car. And the car is traveling fast. Okay, kind of denoted by those awesome little lines behind it. If the car is going fast, okay, by our standards, then we might say that it has a lot of movement energy. Okay. Vice versa, if the object is going slow, you might say it has less movement energy. So one of the things that we have to be careful about when we're talking about kinetic energy is how fast or slow something is going, and in terms of its energy, that will tell us how much movement or kinetic energy it has. So if an object starts out going really fast, but then slows down, okay, and comes to a stop, we would see that its kinetic energy would change. Okay, it would start with a lot of kinetic energy, and you're going to see me use KE for kinetic energy. And here, if it stopped, it would have no kinetic energy. Okay, so one of the things, again, that we have to really take into consideration is how fast or slow an object is going when we're talking about kinetic energy. Okay, so that is kinetic energy, and that is movement energy, and that is how fast or slow an object is going when it comes to their motion and how much energy they have for that motion. But there's another type of energy that objects can have, and it's called potential energy. And while we talked about this in class, there's elastic potential and chemical potential. The one that I want to focus in on today is called gravitational potential energy. All right, so I'm going to kind of flip to a new page here. All right. Gravitational potential energy is energy that is tied to this force of gravity, right? So let's look at an example here. Let's say that we have a cube, and that cube is sitting on a shelf. So let's talk about this cube on a shelf. Let's say that the cube falls off the shelf. Okay, so it kind of goes, whoo, kind of falls off the shelf. There we go. And so one of the things that we would want to say is in order for that cube to have fallen, it had to have energy to fall. Okay, so gravity had to have some way of pulling that object down. And so we would say that that object, that cube, had gravitational potential energy. We like to call this word GPE, gravitational potential energy. Okay. Now, in order for an object to fall, it has to have the ability to be pulled down by gravity. Okay, so gravitational potential energy is the stored energy that an object just has that allows it to fall. Okay, so it is kind of like this energy that an object has that allows it to fall. Now, in order for gravitational potential energy to be present, gravity has to have the ability to pull the object down. So for instance, if the object were to start, let's say on the ground where there's grass, if the object were starting on the ground and it couldn't fall, it would have no gravitational potential energy. If the object starts up really high, okay, let's say even jumping out of an airplane, okay, and we have some skydivers, then if they're up really high, they'd have a lot of gravitational potential energy. Okay, so we're trying to tie two ideas here. You'll notice I've used some same words. Okay, no energy, a lot of energy. For kinetic energy, you have a lot of energy if you're moving fast. And if you're not moving, you have no kinetic energy. For gravitational potential energy, you have a lot of energy if you have the ability to fall a long ways. So this means that the higher you are, the more energy you have. That's a really important idea. The higher you are, the more potential energy, gravitational potential energy, you have. So one deals with speed and one deals with height. Okay, now let's kind of look at the two together. Say I have an object that starts out, maybe it's a bicycle, and it starts out at the top of a hill. Okay, so there's my bicycle. And that bicycle is going to start to roll down the hill. Okay. Well, first of all, the bicycle started up really high. So it's going to have some, you guessed it, nice work, gravitational potential energy. All right, so it's going to have a lot of that because it started out really high, right? If we come over here, all right, we can see that that is really high. However, the bicycle started at rest. The bicycle was barely moving, so it was going really slow at first. Therefore, it has very little to no kinetic energy. Now, as the bike starts to roll down the hill, okay, we see it pick up speed, okay? And then when it gets to the bottom of the hill, the bike is going super fast. Okay, so we need to kind of look at what is happening as the bike is going down the hill. As it goes down the hill, it picks up speed. Gets faster. But as it goes down the hill, it's also getting closer to the center of the earth or getting lower. Okay, so two things are going to happen here. The kinetic energy is going to change because speed is changing. And the gravitational potential energy is changing because the height of the bike is changing. So I want you to predict for me right now. What do you think is happening? Is gravitational potential energy getting bigger or smaller? Is kinetic energy getting bigger or smaller? I'm going to have you take a guess. I want you to write it down in your notes and we'll discuss it when I return to class. Thanks for watching these notes. Please feel free to go back and watch any particular part of them at any time. If you didn't get everything down as you were watching them and you need to pause, rewind, or rewatch, feel free to do so. And we will discuss more of these topics in depth as we progress through this unit on energy. Thanks for watching, and I'll talk to you later.